So, hello teacher, my name is Khang and here's my student ID card.
Hello teacher, my name is Đức and here's my student ID card. And today we will present our topology with network configurations using Packet Chaser, a VLAN setup at layer 2, a layer 3 address analyst, and a web server test with OSI encapsulation. We will explain what we did for each task.
Yeah, so let's start with task 1. Task 1 will be about topology introduction. So this is our topology. We have 4 subnets, subnet A, subnet B, subnet C, and subnet D. So in subnet A, subnet B, subnet C, there will be 4 hosts each, and in subnet D, there will be 8 hosts in subnet D. So to minimize the wasted IP addresses, we allocate the minimal IP range to each subnet. For example, in subnet A, subnet B, subnet C, I allocated the dash 29 for hosts because it can be usable up to 6 hosts. And in subnet D, we use the dash 28. Yeah, so to easily identify the devices on our topology, we mm, set up our name to the device like the PC, router, and switch. In PC, we can see that the PC can 1, PC can 2, PC can 3, and PC can 4. And for the switch, we switch to 1, switch to 2, router to 1 to 2, and server to 1. We also documented the IP address of each device and the default gateway IP address at the router and the IP address of the VLAN in each subnet. So this is our brief introduction to our topology, and now we move on to task 2. So in task 2, Duke will present about layer 2 implementation and VLAN analysis.
In subnet A, we implemented VLANs to segment the network at layer 2. We create 2 VLANs on a switch, VLAN 10 and VLAN 20, with 2 hosts assigned to each VLAN. For example, PCHang1 and PCHang2 are in VLAN 10, and PCHang3, PCHang4 are in VLAN 20. Each VLAN is like an independent LAN, even though they share the same switch. Now we will ping 2 hosts in VLAN 10 and 2 hosts in VLAN 20. The ping within the same VLAN is successful, as expected. All devices in the same VLAN can communicate with each other directly through the switch using layer 2 switching. And now we'll ping PCHang1 with VLAN 10 and PCHang3 with VLAN 20 when the router is turned off. Yes, the inter-VLAN ping fails. The reason is that without a router or layer 3 device, traffic from VLAN 10 cannot reach VLAN 20. The switch keeps VLAN traffic isolated. If we enable the router interfaces for this VLAN, then inter-VLAN communication becomes possible through layer 3 routing. We have configured sub-interfaces on the router or VLAN for VLAN 10 and VLAN 20 with appropriate IP address. Now that the router is turned on, we'll try the ping again. As you can see, now the ping succeeds because the router routes the traffic between VLAN 10 and VLAN 20 at layer 3. The process is PCHang1 ping is sent to its gateway of the router and then forward to the PCHang3 network. Now, I will explain how the VLAN works in traffic. Devices assigned to the same VLAN can communicate with one another directly using layer 2 switching. With 2 devices are part of the same VLAN, their traffic never needs to leave the switch or be routed. However, for communication between different VLANs, layer 3 routing is required. The switch must forward traffic to a router or layer 3 switch. Without this routing capability, inter-VLAN communication fails, even if all devices and switchboard are otherwise functioning. Next, we'll move on to task 3 presented by Khan.
Yeah, so in that way, it will be about layer 3 evaluation. And in this step, I will analyze how ILP and addresses change during communication in each segment. So first of all, I will need to clear the ILP PCK1 to have a fresh start. Oh, yeah, it says no ILP entries found now. That means I have already cleared the ILP. So now I will ping first in the real-time mode before switching to simulation mode to test its connectivity. Yeah, it's successful now. So now I will switch to simulation mode and ping again. So here, when we look at the PCK1, you can see that the source MAC address will be the MAC address of the PCK1, and the destination MAC address will be the MAC address of the router DUC1. That's because the router DUC1 is determined as the next hop for the packet to forward to. Yeah. So, however, in the layer 3, the IP address will remain unchanged from the sender to receiver. Yeah, and that's the network ingress. And for the network egress, I will go to the router to see the difference. So here, that's because in layer 2, MAC addresses will be changed in each segment because MAC addresses will only be valid for the local segments. And in different segments, the MAC address will be different. So here we can see that the source MAC address will no longer be the MAC address of the PCK1, and now it's currently the MAC address of the router DUC1. And now the destination MAC address will be the MAC address of the PCK5. That's where the packet will be forwarded to. Yeah, and also in layer 3, the IP addresses remain unchanged. Yeah, so those are the layer 3 evaluation, and now we move on to task 4. Task 4, Doug will present about web server configuration.
Yes. For task 4, we add the web server to a network in segment D. Our web server's name is server DUC1. It's configured with an IP address in segment D, and we have enabled its HTTP service. The server is connected to the network through router CAN2, so that all PC in other subnet can reach it. First, we'll verify that all hosts can reach the server at the network layer. We'll ping the web server from one PC in each subnet. Yes, we'll see that the web server is reachable from all subnets. Now we'll show the encapsulation process. First, we'll open the web browser application from one PC and enter the web server IP or HTTP request. This whole process is generated in simulation mode. Yes. Now, the PC is sending an HTTP GET request to the server. As we initiate this request, the PC encapsulates the data through the layers. At layer 7, the application data is the HTTP request itself. Then it goes down to the layer 4, where TCP adds a header with source and destination port. Next, at layer 3, an IP header is added with the source and the destination IP address. Then at layer 2, an Ethernet frame is constructed. The PC then adds the source mark and destination mark. And finally, at layer 1 is transmitted as bit on the physical medium. This whole process is encapsulation, wrapping the original data with necessary headers and trailer at each layer. When the packet reaches the router examines the layer 3 IP headers to determine where to forward it. The router then strips off the incoming layer 2 frame and re-encapsulate the packet into new layer 2 frame appropriate for thread D. The layer 3 and above information stay the same. Now, the server receives the packet, it will decapsulate it up the layer. At layer 2, it removes the Ethernet frame. At layer 3, it reads the IP header and sees the packet is for itself. At layer 4, it reassembles the TCP segment. And lastly, at layer 7, the HTTP request is passed to the web server application. Now, as you can see, we have successfully enabled the web browser. And that is also the end of our presentation. Thank you for watching and listening.